Assalamu alaikum wa rahmatullahi wa barakatuh, and welcome back, our dear students. Today, inshallah, paper 4, chapter 1 and chapter 2. No time to waste. Let's secure those marks. The first question we have today, a scientist fills a container with seawater. The container has dimensions of 30 centimeter, 30 centimeter, and 40 centimeter. The density of seawater is 1020 kilogram per cubic meter. Calculate the mass of the seawater in the container. We know there is a link between density, mass, and volume. The dimensions gives us the volume, and of course we have the density. We can find the mass so easily by using this equation: density equal mass over volume, rearranging the equation, making mass the subject, mass equal density times volume. We have the density already. The density equals 1020 kilogram per cubic meters, and the volume will be length times width times the height. So 30 times 30 times 40 will be cubic centimeters. The volume here, you can leave it, it doesn't matter, but the mass will not be in kilogram by this way, but it is better to change it into cubic meters. So the volume, I'm going to multiply the result, whatever the result, by 10 to the power of negative 6 in order to be in cubic meters. So as I told you before, and I'm repeating again, in order to convert from centimeter cube to meter cube, we are going to multiply by 10 to the power of negative 6. And the opposite, of course, if we are going to convert from cubic meter to cubic centimeter, we are going to multiply by 10 to the power of 6, by 10 to the power of 6. Let's find the mass. The mass equal density times volume. What is the density? 1020. What is the volume? 30 times 30 times 40. All times 10 to the power of negative 6. Let's see the result. So 1020 times 30 times 30 times 30 times 10 to the power of negative 2 equal 36.7. In order to write it within two significant figures, I'm going to write 37. 37 what? 37 kilograms. One second. Okay. 37 kilograms. Okay, 37 kilogram, but okay, we are going to keep this aside. The second part, letter P, figure 2.1 shows a submarine. The submarine is fully submerged in the seawater. Okay, we have the hatch, the top surface, and everything. The atmospheric pressure is 100 kilopascal, and the total pressure on the top surface of the submarine is 500 kilopascal. Calculate the depths of the top surface of the submarine below the surface of the seawater. Okay, we have the submarine. We are going to assume here is the submarine, here is the surface of the water. He said the atmospheric pressure is 100 kilopascal. And the total pressure on the top surface here, the total pressure, B total, equal 500 kilopascal. Okay, calculate the depths. Is asking for the depths, is asking for H. What is the total pressure here? The pressure from the water, because we are going to find the depths, and we know the equation P equal rho GH. And if we are going to arrange it to find the depths will be the pressure over rho times G. What is the pressure? The total pressure is 400 kilopascal, kilo by 10 to the power of 3. I'm going to convert it to Pascal for the depths to be in meter. The density is 1020. We just finished with that, and G is 9.8 meter per second squared. Okay, so here is the fraction 400 times 10 to the power of 3 over 1020 times 9.8 equal to 40.0, so it's 40 meters. The depth is 40 meters, reasonable depth and reasonable answer. Double I, a hatch on opening door on the top surface of the submarine had an area of 0.62, so the area equals 0.62 squared meter. Calculate the downward force on the hatch due to the total pressure on the surface of the submarine. So we have already the depth and we have the pressure. The pressure equal 400 kilo Pascal, and is asking for the downward force, F. Calculate the downward force on the hatch due to the total pressure on the top surface of the submarine. So the total pressure on the top surface, total pressure will be, it is given to us 500 kilopascal. So I'm going to change this into 500, because the total pressure on the top surface, 500 kilopascal. So pressure actually equal the normal force acting in unit area. So rearranging the equation, the force equal pressure times area. The pressure is 500. We said kilo times 10 to the power of 3 times the area, which is 0.62. What is the result? And I'm going to write the answer within two significant figures. So 500 times 10 to the power of 3 times 0.62. The answer would be 310 times 10 to the power of 3, or 310 kilo Newton. 310 times 10 to the power of 3 newtons, of course, or 310 kilo newtons. You can write it like this, correct, or like that, correct. Okay. Let's see another question with different idea. Question number 13. Some physical quantities are scalar and other physical quantities are vector. Of course, we can classify physical quantity to scalar and vector. Scalar physical quantity, they have magnitude only, while vector physical quantity, they have magnitude and direction. State how a vector quantity differ from a scalar quantity. As we said, they have direction. So I'm going to write they have direction. This is how the vector are different from scalar. Circle the vector quantity in the list. Acceleration, yes, acceleration is the vector physical quantity. It has magnitude and direction. Energy scalar, mass scalar. Momentum is the vector physical quantity. It has direction. Temperature scalar, time scalar, speed scalar, velocity vector. So the only three vector physical quantities are acceleration, momentum, and velocity. A microphone is recording. Stadio has a mass of 0.55 kilogram and weight W. Calculate the weight. Weight equal mass times the free fall acceleration. We have this equation from Newton's second law. The resultant force equal mass times acceleration. The acceleration here for the weight is the acceleration due to gravity. So what is the mass? The mass is 0.55. What is the acceleration is 9.8. What is the result? Will give us the mass. So 0.55 times 9.8 equal 5.39. So 5.4 newtons, of course, because the mass is in kilogram and the free fall acceleration is in meter per second square. So the force is in Newton. The microphone, here is the microphone, is suspended from the ceiling by a cord attached to a small ring. Figure 1.1 shows the microphone pulled to one side and kept stationary by a horizontal thread. So it's like this, the force here toward the ceiling by this cord is upward, and we have a horizontal force and the weight which acts downwards. And we know the magnitude of the weight. The magnitude of the weight is 5.4 Newton, as we calculated here. Okay. The tension in the horizontal thread is 8.1, so the tension here is 8.1 Newton. Okay, determine graphically the magnitude and the direction relative to the vertical of the resultant of W and T. Use a scale of 1.0 centimeter to 1.0 or greater. So the minimum for the scale given, sometimes the examiner will not give you the scale and you are asked to find it by using your own scale. But since the examiner is forcing us to use that 1 centimeter equal 1 Newton, it will be okay. I'm going to bring my ruler and I want you to do the same, and a blank sheet of paper, and start to draw with me. The sketch will be like this. Here is the horizontal force, which is 8.1 Newton, the first tension, and the second, which is the weight, 5.4. So the resultant will be like this. And he's asking for the angle with the vertical, so he's asking about this angle. Of course, we are going to use Pythagoras theorem. So first I'm going to find my ruler, and I'm going to use the same scale is given. The horizontal line is 8.1. So I'm going to consider the scale. I'm going to use the reasonable place for the drawing. I'm going to start from here, for example. 1, 2, 3, 4, 5, 6, 7, 8.1. 8.1 centimeter. Don't forget the direction, the horizontal, and the magnitude is 8.1 Newton. The tension, and then the weight, which is, as I said, the weight was 5.4. So I'm going to move down 5.4 centimeter. So here is 1, 2, 3, 4, 5, 5.4, 5.4 centimeters. So here is 5 point W equal 5.4 Newtons, or 5.4 centimeter. Then I'm going to measure this. And I'm going to measure the length, and then I'm going to multiply it by the scale. Here is 1 centimeter, 2, 3, 4, 5, 6, 7, 8, 9, 9.9. It's like 9.9. Here is the direction, 9.9 Newton. Here is the resultant force. So the resultant force is 9.9, and it makes angle, if this angle is 34, so it's asking about this. So 90 minus 34, I think 56 degrees. So it's 56 degrees with the vertical. Now I'm going to remove the ruler, and I'm going to go back to the magnitude of the resultant, which is 9.9 Newtons, and the direction of the resultant equal relative to the vertical 56 degree relative to the vertical. If I want to check my working, because I'm not sure, it's like extra is not asking for, I'm going to make the calculation for finding the resultant by using the Pythagoras theorem. So R equals square root T squared plus W squared. So what is T? T is 8.1. So 8.1 squared plus W, which is 5.4 squared. What is the result? Will give us the result. I hope it will be same like mine. So here is the square root, 8.1 squared plus 5.4 squared equal 9.7. So it's a close 9.7. Actually, the answer will be within a certain range. The examiner will give you the answer within a certain range. So we are going to find theta. Theta is tan inverse opposite over adjacent. We need this angle. The opposite will be 8.1, and the adjacent will be 5.4. 5.4. To remind you, here we have the right angle. The side opposite to the right angle is the hypotenuse, and the angle I need to find, the side opposite to it is the opposite side, and the one beside it is the beside, the adjacent. So let's find the magnitude here. We have shift 10, and here is the fraction, 8.1, 8.1 over 5.4, and then let's plot that. It's 56.3, so it's 56 degree. The angle is okay, 56 degree. Of course, I'm using digital tools, and the rule is not that accurate, but while you are using your blank sheet of paper, and everything will be fine. So here is the mathematical method for calculating the resultant force and the angle it makes with the vertical. And here is the calculations, the graphical representation or the graphical calculations for finding the resultant force. Triple I, state and explain how the magnitude and direction of the resultant in C double I compare with the force on the ring due to the tension in the cord. Of course, if we have a force in this direction and the system is balanced, there is the resultant force. If the system is balanced, it means it is equal to the tension in the cord is the same like the resultant force. And since they both acting aligned in the same direction, in opposite direction, so they cancel each other, the system is balanced. Then I explain out the magnitude of the and direction of the resultant in C compared with the force on the ring due to the tension in the cord. I'm going to say they are same as the system is balanced. So resultant force is 0. So we are done for the second question. I think this is enough for chapter 4. Assalamu alaikum wa rahmatullahi wa barakatuh.